The universe is 13.8 billion years old. The observable universe is 93 billion light-years across. Both of those numbers are correct. They cannot both be true at the same time, and yet they are. Scientists mapped the full extent of the observable universe using data from the Planck satellite in 2013. Most people who hear both numbers in the same sentence never recover their intuition about space. The fastest spacecraft humanity has ever launched would take 37,000 years to reach the nearest star, and that is our closest neighbor. The Milky Way has 400 billion more, and 97% of all galaxies are already permanently unreachable. Not because we are too slow, but because space itself is expanding faster than any ship we could build could ever cross. Tonight, we'll trace three things: how a universe 13.8 billion years old became 93 billion light-years wide, where the 97% went, and what it means to exist inside a cosmos that is already mostly beyond reach. By the end of tonight, you'll understand exactly why the numbers don't add up, and why that changes nothing about what you are. If this is the kind of night you return to, subscribe. It helps this quiet universe keep growing. Let's begin. Let the mind show you its own edge, gently. With nothing more than a few coins on a table, lay down 3 of them in the dark, and you know there are 3 without thinking, without counting, the way you know your own hand. Lay down 4, and it is still that easy, still instant, but set down 7, and something shifts, soft and almost unnoticed. A small effort arrives, a quiet falling back, and you are no longer simply seeing the number, you have begun to approximate it. And if you stay still enough, you can feel the seam where one way of knowing hands the night over to another. That seam has a name. The instant kind of knowing is called subitizing, and for nearly everyone alive it gives out at 3 or 4, no further. Everything above that is carried by what is called the approximate number system, the older, dreamier faculty that judges the size of a crowd, the depth of a distance. It is ancient, and it is shared, woven through the minds of crows and infants and fish in the slow dark of the sea. And it works in soft ratios rather than in hard totals. It can tell 60 apples from 30 without trouble. It cannot tell 60 from 61, and it has never once felt the need to try. What that means for a sky full of numbers is a quiet kind of mercy and a quiet kind of blindness. Folded together, the approximate system compresses. The more you hand it, the more it presses the differences gently out of view. To that older part of the mind, a billion and a trillion come to rest almost on top of one another, both simply enormous, both filed beneath the same soft heading, the vast gap between them smoothed away into nothing. And yet the gap is not nothing. A trillion is 1,000 billions. If a billion seconds is 32 years, then a trillion seconds drifts back past the last ice age, past the first cave paintings, almost to a time when the earlier cities had not yet been dreamed. That whole long reach is the distance the mind quietly erases without ever telling you it has done so. So every cosmic figure you have ever heard came to you, already softened, already rounded down at the door. The 100 billion stars, the 2 trillion galaxies, the 14 billion years, each arrived pre-shrunk, folded into the same patient word before you were ever consulted. The universe was filed under large, and the filing was done long before you could think to object. And this is not a flaw to be ashamed of. Lying here in the dark, it is the equipment working exactly as it was built to work. A mind that needed to weigh how many wolves stood at the tree line, how many days of food remained in the store, never once needed to hold a trillion of anything. And so the ceiling was set, gently, by what kept us alive. And what kept us alive simply stopped caring somewhere around the number 4. It leaves us, though, in a strange and lovely position tonight. We are about to climb a long, slow staircase of sizes, and every single step on it is a leap as wide as the one from a fortnight to a lifetime. From planet to star. From a single star to the whole turning galaxy. From the galaxy to the vast web that holds the galaxies like dew. No step is merely a little larger than the last. Each is 1,000-fold, 1,000,000-fold, a leap the intuition cannot truly make, and will, in its gentleness, quietly pretend it made anyway. And the first of those steps is the smallest one we will take all night. A single unit, invented long ago to make these distances sayable, and meant, with the best of intentions, to rescue us. The strange thing is that it does the opposite. It does not shrink the gap at all. It only hides it, softly, beneath two friendly words. That unit is the light year, and it sounds, at first, like an act of kindness. One small phrase doing the work of a number far too long to ever read aloud. Light, travelling for a single year. Surely that is something a tired mind can hold. So begin with the speed. Slowly, because the speed is already far beyond us. Light moves about 300,000 kilometers in every second, and in the time it takes to murmur the word light, a single beam of it could circle the whole of the Earth more than 7 times over. Nothing in all the universe moves faster. Nothing catches it, nothing ties it, nothing comes anywhere close. It is the absolute patient ceiling on how quickly anything at all can cross from one place to another. Now let that beam run, at that unimaginable pace, without ever slowing, for 1 full year. The distance it quietly covers is what we have chosen to call a single light year. Written out in plain kilometers, it is a 9 trailed by 12 more digits. A figure you could read aloud but could never feel. And that gap between reading and feeling is the whole of the trouble. The unit was meant to close it. Instead, it folds the unfeelable number into 2 soft syllables and hopes, kindly, that you will not look underneath. So let us look underneath, gently, using the one thing the body still understands. The size of things. You could almost reach out and touch. Shrink the sun, that vast 1,000,000-kilometer furnace, down to a single marble you could close inside one hand. At that scale, the whole of the Earth becomes a single grain of sand, and it drifts about a meter away. Our entire world, every ocean and every city and every life that has ever been lived, a speck, a meter, from a marble, and distant Pluto, on that same quiet table, has wandered off somewhere past the far wall of the room. And the nearest star, then, on that same gentle scale, marble sun, sand grain Earth, a meter off in the dark. The very next star is another marble, and it rests roughly 300 kilometers away. Not across the room, nor even across the city, but in another city altogether, with nothing but soft emptiness the whole long way between. That is what the kind little word was holding out of sight. Between our marble and the next, you could lay down the full length of a country, and then go searching through all of it for a single grain of sand somewhere near the middle, and call that lonely grain home. This is the slow move the universe will make again and again through the night. So it is worth naming now, while everything is still close. We reach for some tool to make the scale bearable. A unit, a soft word, a comparison the body can hold. And the scale simply absorbs the tool, without resistance, and keeps on drifting outward. The light year never made the distance any smaller. It only made the distance quiet. It let us file the 4 and a bit light years to the nearest star beneath the gentle heading of not far, in cosmic terms, when the slow truth is that the gap is so wide our fastest machine could not cross it in the whole of recorded history, several times laid end to end, which is, perhaps, the next soft thing the word will never tell you, because we have, in fact, built such a machine and aimed it outward and let it run for half a century into the dark. Voyager 1 left the Earth in 1977 and never turned back. It is the most distant thing our hands have ever made, drifting now somewhere out past the edge of the sun's long reach, still calling softly home in a whisper that takes the better part of a day to arrive. It moves at around 17 kilometers in every second. Quick enough to cross a continent in a few quiet minutes. Quick enough that nothing human-made has ever traveled faster from the Sunday. And yet, against the dark, it is barely moving at all. Imagine, gently, that we had aimed it at the nearest star, not where it is truly drifting. For Voyager is bound for no one in particular, but dead at that next marble, 300 kilometers down the dark road we walked a moment ago, at 17 kilometers a second, the crossing would take something on the order of 70,000 years, and it is worth resting inside that number for a while, slowly, because the dreaming part of the mind will try to swallow it whole and move on. 70,000 years ago, our kind had not yet pressed a single painting onto a cave wall. There was no farming, no writing, no wheel, nothing we would recognize as history at all. Had a Voyager set out then, carrying some patient message toward the nearest star, it would still be out there tonight, somewhere in the long dark, not yet even halfway. Because there is no hurry out there that means anything. Whole civilizations would rise and forget themselves and quietly rise again. Languages would be born and grow old and fall silent. The ice would come and soften and come again, and the small craft would simply keep falling onward through the night, unbothered, unfinished, unarrived. And remember, gently, what this distance is. It is the smallest one in the entire sky, the shortest single hop between stars that exists from where we lie. Every other star in the galaxy is farther, most of them vastly, almost unaccountably farther. We are measuring the very nearest neighbor we have, and finding that our greatest machine, set running for longer than human memory itself, would still be quietly on its way. There is something in this that has nothing at all to do with despair. If you let it settle, the galaxy was never built to the scale of a journey. It was built to the scale of patience, of light, which holds all the time there is, and of gravity, which has never once been in a hurry. We are the ones who arrive measuring everything in lifetimes. The universe simply does not keep its quiet accounts that way. A star does not think 70,000 years a long while. A star is barely stirring in its sleep on a span like that. So we will not cross these distances, not with rockets, not with anything that throws mass out behind it to move. And the honest, gentle truth is that the nearest star, for any body and any single life, lies permanently out of reach, which only widens the dark a little further and lets the floor drift softly down, because that one unreachable star is a single point of light among a few 100 billion in our galaxy alone, all of them held inside a vast, slow structure we have studied from within for the whole of our history and have somehow never once seen. Every photograph of the Milky Way you have ever quietly admired, that grand, glowing spiral, the arms wound soft and tight around a burning core, is either a painting or a portrait of some other galaxy standing patiently in for our own. We have never once taken that photograph, and we never will. There is no way to step outside, turn the camera gently around, and hold the whole thing in a single frame, because we are buried far down inside it, about halfway out along one of its quiet arms, looking ever outward through the drifting smoke of our own home. That soft band of light some of us can still find on a truly dark night. The one the old stories called a river, or a road, or a long, slow spill of milk, is the galaxy itself, seen edge on from deep within. We live inside the disk, and so the disk wraps all the way around us as a faint ring of light, and we read it the way a single drop of water, turning in a vast, slow whirlpool, might catch the curve of the whole and never the shape. The shape itself is hard won, and gently uncertain. We have measured it the patient way, over long years, tracking the stars, timing the drifting gas, reading the slow orbits, and our best understanding is a barred spiral somewhere around 100,000 light-years across. Light itself, that thing which laps the Earth 7 times in a heartbeat, would need 100,000 years simply to drift from one edge of our galaxy to the other. We do not even know its true width with any confidence. We are still, quietly, arguing over how many arms it really has. It is no simple thing to survey a house you may never leave. And then there is the turning. The whole vast disk rotates, slowly and without sound, and the sun rides along with it, carrying us at something like 200 kilometers every second around a center we cannot see. A center hidden behind thick, drifting lanes of dust, where a black hole some 4 million times the mass of the sun rests in the dark. At that pace, a single circuit of the galaxy takes somewhere near 230 million years. 1 galactic year, which means the last time the sun rested in this exact place along its long orbit, the dinosaurs had not yet reached their fullness. The continents wore unfamiliar shapes. No flower had yet opened. We have drifted through perhaps a fifth of one circuit since the first of our kind stood upright. And the sun has not come round even once in the whole history of everything we are. We are passengers aboard something so large and so slow that a single one of its years is longer than the lifetime of every creature that has ever paused to watch it turn. So we pass our whole lives inside a structure we cannot photograph, cannot cross, cannot fully measure, and have never once seen turn to face us. And the gentlest, strangest part is this, that this unseeable, uncrossable galaxy, the entire quiet stage of every story our kind has ever told, is only one of those 2 trillion. A single grain of light, held inside something far larger, and it does not even drift freely. It is being drawn, slowly, all of it together, towards something far out in the dark that we still cannot quite see. The pull has a direction, and for a long while we could feel it without ever finding its source. Our galaxy, and the dozens bound softly to it, and the thousands beyond those, are all sliding the same way through the dark at hundreds of kilometers a second, drawn toward a region the astronomers named, plainly and a little uneasily, the Great Attractor. The trouble was that it rests almost directly behind the dense, glowing heart of our own galaxy, in the patch of sky we call the Zone of Avoidance, the place where our own dust and stars crowd the view so thickly that, for a long time, we simply could not see whatever was drawing us in. We knew the direction of the fall. We could measure its quiet speed. We just could not see the bottom of the slope. A whole region of the cosmos was tugging gently on everything we are, and our own home stood in front of it the entire while, softly holding up a hand. In 2014, a team led by an astronomer named Brent Tully tried looking at it a different way. Rather than mapping where the galaxies are, they mapped where everything is quietly flowing, tracing the slow currents of motion across the local universe, the way you might find the true shape of a valley by following which way all the rivers choose to run. And out of those currents, slowly, a structure resolved that no one had ever drawn before. A vast basin of galaxies, all of them draining gently toward the same low point. All of them part of a single connected sweep of space. They called it Laniakea. The word is Hawaiian, and it means immeasurable heaven, and it was chosen with great care, almost as a soft apology. Laniakea holds something near 100,000 galaxies, and it stretches more than 500 million light-years from edge to edge. Our entire galaxy, with its 100,000 light-year span and its slow quarter-billion-year stride, is a single quiet thread near the outer rim of the thing, not at the center, not anywhere of importance, just one of 100,000, caught in the same gentle current toward the bottom. So the structure runs deeper than we have any real feeling for, and it is worth letting it settle one slow layer at a time. The solar system, drifting inside the galaxy. The galaxy, held within a cluster of galaxies. The cluster, folded into Laniakea, a supercluster so impossibly large that the ones who found it reached for a word that gently admits defeat. And every rung of that long ladder is one of those leaps as wide as a lifetime, the kind the mind cannot truly take. There is something almost tender in being a single thread inside a current you will never feel. We feel perfectly still. Lying here, we feel, if anything, like the quiet fixed point around which the whole night slowly turns. And we are, in truth, being carried, gently, ceaselessly, without our consent and without our resistance, toward a low place in the dark we have only lately learned to name. Yet Laniakea itself is only one of millions of such structures scattered through the visible universe, and between them the map turns strange and soft and dark, because for all our talk of galaxies and clusters and immeasurable heavens, the overwhelming part of the universe holds none of it, and there is one near neighbor moving against the whole slow tide, not away with the rest of us, but quietly closer. Almost everything in the universe is drifting away from us. That is the deep, quiet background condition of the whole cosmos. Space itself slowly stretching, carrying the galaxies apart like soft marks drawn on the skin of a balloon as it fills. The farther a galaxy lies, the faster it recedes. And so to run the eye across the whole of the sky is to watch a slow, universal withdrawal, a tide going gently out in every direction at once. Andromeda is the one exception. The great spiral, 2.5 million light-years off, the most distant thing the unaided human eye can find on a clear and truly dark night, is not withdrawing at all. It is drawing closer. Its light arrives shifted softly toward the blue, the quiet fingerprint of something falling nearer. At around 100 kilometers a second and slowly gathering pace. The reason is gravity, quietly winning a local argument against the expansion of everything. Up close and 2.5 million light-years still counts. Out here, as up close, the pull between two great galaxies is stronger than the slow stretch of the space trying to part them, and so we are bound softly to Andromeda. The way two stones let go on the same gentle slope are bound to roll toward one another. We are rolling. In roughly 4 to 5 billion years, the two galaxies will meet. It will not be a collision in any sense the word usually carries. And there is a strange calm in that. Galaxies are mostly emptiness. The gaps between their stars are so vast that almost nothing will actually strike anything at all. Instead, over hundreds of millions of slow years, the two great spirals will wheel through and around each other, drawing out long luminous streamers of stars, stirring the quiet gas into soft bursts of new suns, slowly losing the shapes they have held for billions of years. In time, the two cores will settle gently into one, and the spiral arms that defined both galaxies for so long will be gone, smeared softly into a single vast glow of old light. Some astronomers have already, fondly, given the result a name: Milkomeda, or Milkdromeda, if you prefer the softer sound of it. The sun will most likely still be burning when this slow meeting comes, though our world will be a changed and harder place by then, for reasons all its own. Whatever is here to watch, if anything still is, will see Andromeda swell across the whole of the sky over the course of ages, until there is no night without it, until the two galaxies are no longer two. And so even the great withdrawal of the universe is not the whole of the truth. Inside each gravitationally bound pocket, the old gentle rules still hold. Things fall together and merge and quietly become one. The expansion governs only the long gaps between the islands, never the islands themselves. We are not only being carried down toward the great attractor, we are also, on a nearer and softer schedule, falling slowly into the arms of the one large galaxy near enough to hold us. And that word near is doing an enormous amount of quiet work, because Andromeda is the closest large galaxy there is, and it rests 2.5 million years of light away. Beyond our small-bound family, The distances stop being counted in neighbours at all and begin, instead, to be measured in emptiness. We tend to speak of the universe as though it were full of stars, full of galaxies, a vast glittering everything pressed edge to edge. The slow map says otherwise, gently. When you chart the largest structures there are, the galaxies do not spread evenly through space like sugar stirred soft into water. They gather into long threads instead, luminous filaments with bright knots where the clusters quietly collect, woven into a pattern the astronomers call the cosmic web. And a web, by its very nature, is mostly the soft holes between the strands. Those holes have a name: voids. Enormous, almost perfectly empty rounds of space, where there is so little of anything that you could drift for hundreds of millions of light years and pass scarcely a single galaxy. By sheer volume, the voids are the universe. The shining filaments are only the thin, bright borders, and the vast, dark rooms between them are where most of the cosmos truly lies. If you closed your eyes and chose a point in the universe at random and softly set yourself down there, the overwhelming likelihood is that you would open them onto nothing. No near star, no near galaxy, only a darkness so complete it has no honest comparison anywhere on Earth. There is one void we have come to know especially well, because its sheer size gently startled the people who found it. The Boötes Void, charted in 1981, is something near 330 million light-years across, an almost perfect bubble of near-nothing. When it was first mapped, it held so few galaxies that one astronomer made a remark that has lingered ever since, that if our own Milky Way had happened to rest at the centre of the Boötes Void, we would not have known other galaxies existed until somewhere in the 1960s. Let that settle slowly, because it is a stranger and quieter thought than it first seems. The whole long human story of looking up, every culture's gentle myths, every early telescope, the slow dawning that those faint smudges were other distant islands of stars, all of it leaned on having neighbours close enough to notice. Set us down in the deep middle of a great void, and the night sky would be nearly bare, a soft scattering of our own galaxy's stars, and beyond them, almost nothing at all. We would have built our quiet cosmology certain that the Milky Way was the whole of the universe, and we would have been gently, completely wrong, with no way on Earth to find it out for the better part of forever. We were not born in a void, and there is a soft fortune in that. We were born on a thread, in a crowded and luminous little corner, with Andromeda near enough to see and 100,000 galaxies flowing alongside us toward the attractor, which is, as it happens, the one position from which the true scale of things is even discoverable at all. Somewhere out in the Boötes dark, there may be quiet worlds whose night sky tells them, softly and falsely, that they are entirely alone, and they have no reason in all their evidence to doubt it. The emptiness is not a flaw in the universe. It is the larger and older part of what the universe simply is. The galaxies are the rare, bright exceptions, and the dark between them is the patient rule. And it raises, very gently, a question we have been quietly drifting around all night, because we keep saying the universe as though we could see the whole of it, when in truth the part we can see has an edge, and that edge is not where the mind expects, and it is not made of anything the mind would guess. The universe is about 13.8 billion years old, and light is the fastest thing there is, and so a reasonable, resting mind concludes that the farthest we could ever see in any direction is 13.8 billion light-years. Light that set out at the very beginning and has been drifting toward us ever since. It is a perfectly reasonable thought. It is also, gently, wrong. The edge of the observable universe does not lie 14 billion light-years away. It rests around 46 billion light-years off, in every direction at once, which makes the whole visible sphere something near 93 billion light-years across, far wider than the distance light itself could have crossed in all the time that has ever existed. It is the kind of fact that sounds at first like a small mistake, like a digit lost somewhere in the dark. It is not a mistake. It is one of the truest and strangest things about the place we live. The gentle resolution is that space itself has been stretching the whole time the light was in flight. Picture a beam setting out, long ago, from some young patch of matter that would one day cool and gather into a distant galaxy. While that beam drifted toward us across billions of years, the space between us and its source kept quietly lengthening, stretching the road even as the slow traveler walked it. The light arrives having genuinely covered some 13 billion years of travel, and yet the place it began has, in all that time, been carried far, far beyond where it stood when it first let the light go. The light is old. The distance is now enormous. Both of these are true at once, because the ground itself grew softly beneath the journey, and this is the moment where the gentle little unit finally turns, quietly, against us. A light year was meant to be a distance and a time locked together. Light, 1 year, one fixed and trustworthy length. But once space is stretching, the two slip apart from one another. How far the light actually traveled and how far away its source rests now are no longer the same number, and they are no longer even close. The thing we measure and the thing that truly exists have drifted gently into two different answers to one simple question. So when we say the observable universe is 93 billion light-years wide, we are not describing how far the light has come. We are describing how far away, at this very moment, the most distant things we can still detect have been quietly swept. The number is the width of a soft bubble, a bubble of everything whose light has had time enough to reach us. And it is centered, as nearly as any instrument can tell, precisely on the Earth, which is the next gentle place the mind loses its footing. A bubble has a center and an edge, and it feels only natural to picture ourselves resting at the very middle of the universe, gazing outward toward its distant walls. We are at the center of something, but it is not the center of the universe, and that far edge is not a wall. It is woven out of time rather than space, and, strangest of all, it belongs to you alone, and it drifts wherever you drift. The observable universe is not the universe. It is only the part of the universe that anyone resting in exactly your place could ever have received light from. Those two things sound nearly the same in the dark, and they are not the same at all. One is a place, the other is a point of view. Every observer, anywhere in the whole of the cosmos, rests at the soft center of their own observable bubble, a sphere of everything close enough in space and old enough in time for its light to have quietly arrived. Yours is centered gently on the Earth. Some creature in a galaxy 10 billion light-years from here floats at the center of its own bubble, mostly overlapping with yours but never wholly, and out at the far dim edge of all you can see there are regions you will never once observe. While from those very regions a different watcher sees a different far edge, with us resting near the soft limit of their sight. There is no shared boundary anywhere. There is no single rim that everyone agrees is the end. The edge is gently, irreducibly personal. And it is not a wall. When we gaze toward the limit of the observable universe, we are not seeing some barrier where space itself stops and gives out. We are seeing as far back into time as light will allow. And then, just beyond, to a moment before the universe had even cooled enough to let light travel freely at all. The edge of the observable universe is the soft edge of seeing, never the edge of being. Past it, space almost certainly drifts on, galaxy after galaxy, in every direction, exactly as it does here around us. We simply cannot get the news. The light has not yet had the time, and for much of it, it never will. So let go, gently, of the picture of a sphere with us resting proudly at its middle. The universe has no known center, because every single point within it holds an equal claim. Each one can look slowly out and find itself surrounded on all sides. Each one can softly call itself the middle of everything. It is a little like asking which point on the surface of a balloon is the center of that surface. There simply isn't one. The center is not on the surface at all. Wherever you happen to be is the only place from which you can ask the question. And from there, the answer comes back always the same, quiet and untroubled. I appear to be in the middle. Everyone is right. Everyone is the center. And so, gently, no one is. There is a soft and unexpected comfort folded into this, the kind that only arrives after the vertigo has passed and the breathing has slowed. You spent the early part of tonight learning that the mind rounds the whole universe down to almost nothing, that you are a single grain of sand beside a marble, a thread inside a current you will never feel, one quiet point among 2 trillion. And now the universe turns, slowly, and lays the center of everything that can be seen into your hands. Not because you matter to it. It holds no opinion of you whatsoever, but because seeing always happens from somewhere, and your somewhere is here, in this bed, in this dark. Yet the bubble it has gently given you is not a still or a settled gift. It is quietly leaking. Most of what you can see within it tonight, you are in truth watching slowly leave. And it is leaving in a way that no speed, and no patience, and no machine we could ever build will undo. Here is the gentlest way to hold the hardest fact in all of cosmology, and it is worth saying slowly because the mind will quietly try to refuse it. Of all the galaxies we can see in the night sky tonight, the ones whose light is arriving in our telescopes at this very moment, we could never reach the overwhelming majority, not in a lifetime, not in 1 billion lifetimes, not even if we set out this instant at the full speed of light itself. They are, softly and already, gone. The number, worked through with great care by the cosmologists Charles Lineweaver and Tamara Davis, is a quiet kind of heartbreak. Something like 94% of the galaxies we can currently see are already beyond any reach. We receive their light. It is touching our instruments right now, and yet if we sent a beam of light back toward them this very second, the fastest possible messenger, the thing that nothing in existence can outrun, that beam would never, across all of time, arrive. The galaxies are receding faster than light can ever close the gap, carried gently away on the long stretching of space. And the space between us is widening faster than any signal could cross it. This does not break the old law that nothing travels through space faster than light, and there is a soft logic to it once you let it settle. Nothing is moving through space here at all. Space itself is stretching, everywhere at once, and there is no rule anywhere that limits how quickly distance alone may grow. Each small stretch of space adds only a little speed, but there is so very much space lying between us and a distant galaxy that all those little additions gather, quietly, into more than light could ever overcome. We see the light that left long ago, when the gap was still narrow enough to cross. The galaxy that sent it has since been carried past a line, a soft, cosmic horizon, beyond which no message of ours could ever follow. So the night sky is, in great part, a slow record of farewells. We are gazing at the light of galaxies we are seeing and losing in the very same instant, present to our eyes, and permanently absent to anything else we could ever do, or send, or hope. A child could lift a hand toward one of them and say, softly, "I want to go there." And the honest answer is not that it is simply too far. The honest answer is that the road is being unmade behind the light faster than anyone could ever walk it forward. The galaxy was reachable once, in principle, for some traveler who set out early enough in the life of the universe. That gentle window has long since closed. It closed before any of us were born. This is the one, I think, that quietly refuses to fit, even after all the others have found their places. A great distance you can imagine crossing, given only enough patience and enough time. But this is a distance that grows on purpose, gently, to keep you out. Not a far shore, but a shore that withdraws faster than any boat could ever follow. The light arrives like a postcard from a place that no longer takes visitors, and never will again, and the postcard is warm in your hands. And the horizon that draws it away is not even holding still, it is closing slowly inward, over spans of time that dwarf everything we have drifted through tonight. More and more of the sky is crossing that quiet line, slipping out of reach, and then, in time, out of sight altogether. The universe we can see is not only vast and mostly unreachable, it is, very gently, growing smaller. The sky is beginning, without a sound, to go dark. The expansion of the universe is not slowing down. For a long while we quietly assumed that it must be, that gravity, pulling patiently on everything there is, would gradually rein in the long outward drift. And then, at the close of the 1990s, two teams measuring the light of distant exploding stars found the gentle opposite. The expansion is speeding up, something we still do not understand, which we call dark energy for want of any better or softer name, is pressing space apart faster and faster as the ages pass. Follow that slowly forward, and the night sky turns out to have an ending. As the expansion quickens, more and more distant galaxies are carried across the cosmic horizon, over the soft line past which their light can no longer reach us. They do not vanish in any sudden moment. They redshift. Their light stretches longer and longer, dimmer and dimmer, sliding gently toward invisibility, until one quiet day, the last photon any of them ever sent our way finally arrives. And after that, from that galaxy, nothing more, ever. It is still out there, somewhere in the dark. We simply receive no further word from it for all the rest of time. The cosmologists Lawrence Krauss and Robert Scherer worked slowly through what this means for the deep future, and the conclusion is quietly devastating in the gentlest possible way. Given enough time, 100 billion years, a few 100 billion every galaxy beyond our own bound, little group will have drifted across that horizon. By then, the Milky Way and Andromeda and the rest of the local group will long since have merged softly into a single galaxy, and around that lone island, in every direction the eye could turn, there will be nothing visible at all. A black, empty sky beyond our own scattering of stars. No other galaxies, no cosmic web, no evidence, anywhere, that the rest of the universe was ever there to begin with. And it is worth resting, gently, with the astronomers of that far age. They will build their patient telescopes and aim them outward and find one galaxy, their own, surrounded on every side by perfect dark. With the honest evidence they are given, they will conclude that the universe is small and still and singular. They will have no way to discover the expansion, no distant galaxies to watch withdraw, no soft background glow left to read, because all of it will have slipped quietly beyond the reach of any instrument they could ever raise. They will be doing careful, rigorous, honest science, and they will be completely wrong, and there will be no way, anywhere in their sky, for them ever to know it, which turns a soft light back onto us. Lying here tonight, we are not resting at some random moment in the long history of the cosmos. We are living inside a narrow, quiet, privileged window, early enough that the galaxies have not yet fled, that the most ancient light still reaches us, that the true scale of the universe is still written gently across a sky we can still read. The evidence is, right now, in our hands, and it is, slowly, in the act of disappearing. We happen to be here while the book is still open. In the soft hours before the pages, one by one, drift quietly blank. So, when we ask how large the universe truly is, we are asking it in the last age, when the question can even be looked into. And even now, with the book still open in our laps, the honest answer is that we do not know, and that the part we can measure may be the smallest, faintest corner of the whole. Everything we have drifted through tonight, the marble sun, the unreachable star, the unseeable galaxy, immeasurable Laniakea, the great dark voids, the 93 billion light-year bubble, all of it rests inside the observable universe, the part whose light has had the time to reach us. And the observable universe is not the universe. It is the lit room. The rest of the house lies in darkness. And we do not know, even now, how many rooms there are. How much larger is the whole than the small lit part we can see? Here, gently, we reach the edge of what anyone can honestly claim. The truthful answer is that we do not know, and that we may never know, and that the not knowing is not some temporary gap waiting quietly on a better telescope. It is built into the very shape of the situation. The unobservable universe is unobservable by its nature. Its light has not reached us, and for much of it, it never will. We are trying to measure the size of a house from inside a single sealed room by the faint sounds that drift in through the walls. What we can do, softly, is set a floor beneath our ignorance. The universe is flat, as far as the most delicate measurements can tell. Flat to within a very small margin. And a flat universe, if it is finite at all, must be enormously larger than the part we can see. Some careful estimates set the lower bound at hundreds of times the volume of the observable universe. Others, drawing on the theory of cosmic inflation, the idea that the infant universe ballooned outward by an unimaginable factor in the first sliver of its first second, gently suggest that the true universe may be larger than the observable part by a factor so vast that it makes 93 billion light-years look like the marble resting on the table. And the simplest reading of a flat universe is the one that unsettles people most softly of all. It may not be larger by any finite factor whatsoever. It may simply be endless. No edge, no total, no number left to round quietly down, because there is no number there to round. We genuinely cannot tell the difference from in here, and there is a strange peace in admitting it. A universe that is merely unthinkably large, and a universe that is truly without end, look exactly alike from inside a sealed and lamplit room. Both simply keep on, past the wall, with no way at all to lean out and check which one goes on forever. The most basic question a child might softly ask, lying in the dark, how big is everything, turns out to be one that the very structure of reality may quietly forbid us from ever answering. Not too hard for us, not merely unsolved as yet, possibly closed to us, permanently and gently, by the nature of light and time and the room we happen to be born inside. So set down, at last, the picture of the universe as a thing with a size you could hold. The part we can see is already vast past the soft place where the mind gives way, and it is the small part, a single bright bubble, resting inside a dark we cannot measure and may never be able to measure even in principle. All of tonight has been a slow tour of the lit room, and the lit room alone has gently broken our sense of scale a dozen times over. The dark is larger, we do not know by how much, and now, softly, turn the whole thing the other way, because the same scale that runs outward, past every horizon, into the maybe endless, also runs the other direction, inward, into you, and it does not grow any smaller there. The scale does not only run upward and outward, it runs downward and inward as well, just as far, and the place it quietly arrives is the body lying here in the dark. Consider, slowly, what you are made of, not in any poetic sense for now, but simply by the count. A human body holds something on the order of 7 octillion atoms. That is a 7 trailed by 27 zeros, a number that drifted off the soft edge of intuition so long ago that writing it out is very nearly a joke. Now lay it gently beside the stars, the observable universe, that 93 billion light-year bubble, the 2 trillion galaxies. Every sun burning in every one of them holds somewhere around a figure with 22 or 23 zeros worth of stars. The arithmetic is quietly staggering, and it points back inward. You hold, by a wide and comfortable margin, more atoms than there are stars in all the galaxies we can see. The cosmos we cannot comprehend is outnumbered, many times over, by the soft machinery of a single resting body. And those atoms are not little solid beads pressed together. Each one is mostly empty space, a tiny dense nucleus, with a faint haze of electrons drifting far out around it, and a vast, patient emptiness in between, the very same kind of emptiness we found resting between the stars. If you could gently remove all the empty space from every atom in every human being now alive, and press the actual matter softly together, the whole of our species would settle into a volume smaller than a sugar cube. The solidity of your own hand, resting there against the sheets, is very nearly a sensation built out of almost nothing at all. Quiet fields and patient forces, holding empty space gently apart and persuading you, kindly, that there is something there to feel. So the same two truths that govern the very largest scales also govern the smallest. Mostly emptiness, and quantities that drift far past the soft wall of comprehension. The void between the galaxies has a faithful, miniature twin in the void inside every atom of your hand, and the whole count of stars in all the heavens is gently outnumbered by the count of particles it took to assemble the warm, breathing weight of you. This is not the familiar move, where the body is shrunk against the sky until it quietly disappears. It is the slow opposite, held up against the universe by the one measure that flatters neither side, by sheer number alone. The body does not vanish into the dark, it answers. There are more pieces in you than there are suns in everything you can see, and every one of those pieces was gathered patiently over billions of years from the soft wreckage of stars that lived and died long before the sun was ever lit. The largeness, it turns out, is not only far out there, beyond every reach, on the far side of the horizons. It is also here, beneath the blanket, in the small dark space your ribs make and unmake each time you breathe. And there is one old, worn comparison the universe keeps gently inviting us to make between the two, between the things of the sky and the smallest things we can hold in a hand. And it is worth making at last, but only if we make it slowly, and honestly. You have almost certainly heard the comparison before. There are more stars in the universe, it goes, than there are grains of sand on all the beaches of the earth. It has been repeated so often, and so gently, that it has gone soft, the way a coin goes smooth after too many years in too many pockets. So let us not simply repeat it tonight. Let us slowly check it, and then go looking, quietly, for the part that the worn old version always leaves out. Count the sand honestly. Every beach, every desert, every grain along every shore, and every dune on the whole turning planet. And careful estimates settle somewhere around 7 followed by 18 zeros. An ocean of grains, far more than any mind could ever picture, which is rather the soft point of it. And the stars in the observable universe outnumber even that. Not by a little, by something on the order of 10,000 to 1. For every single grain of sand on every beach and in every desert on the earth, there are roughly 10,000 stars burning, quietly, somewhere in the sky. But here is what the smoothed over version always lets slip away, and it is the part that gently matters most. A grain of sand is a fleck of mineral smaller than a single letter on a page. A star is a sun. Each of those 10,000 points of light, counted against each grain, is a furnace 1,000,000 kilometers across, pouring out its slow energy into the dark, very often ringed by quiet worlds of its own. The comparison is not really sand against sand at all. It is the smallest dead thing you could hold in a hand, weighed against the largest living engines in all of existence. And the engines win, 10,000 to 1 against the grains, with every one of them larger than the whole world that all the grains are resting on. And I will be honest with you about something here, softly, because the night is the right time for it. There is no good analogy for this. The sand comparison is the finest one we have, and it still quietly fails because the two halves of it are not the same kind of thing at all, and the dreaming mind cheats gently in the dark, imagining 10,000 more grains rather than 10,000 more suns. When the comparison is truly doing its work, it should not feel comfortable at all. It should feel like the soft floor giving slowly way beneath you. If picturing it settles into something pleasant and easy, then the picture has gone wrong, and the approximate number system has quietly rounded the suns back down into sand again, simply to make them fit inside the room. So hold the failed comparison anyway, gently, failure and all. Tonight, on some dark and quiet beach on the turning earth, the slow tide is lifting and setting down more grains than a person could count in 100 lifetimes. And for each one of those grains, the sky keeps 10,000 fires. The number itself is not the wonder. The wonder is that the number is real, and out there, drifting on, whether or not a single mind anywhere is awake to round it softly down. And all of this, the suns past all counting, the unreachable galaxies, the maybe endless dark, all of it is young. We are in the slow habit of calling the universe ancient, and it is by every human measure. But against its own long future, the universe has only barely begun to open its eyes. Carl Sagan once gently compressed the whole history of the universe into a single year, and the quiet trick of it still works, because it sets the dates down where the body can almost feel them. Let the Big Bang fall on the first soft second of the 1st of January. On that scale, the Milky Way gathers itself together somewhere in the spring. The Sun and the Earth do not appear until late in the summer, in the early days of September. The dinosaurs arrive on Christmas Eve and are quietly gone again by the 28th. And all of recorded human history, every empire, every language, every name that anyone has ever loved or spoken, folds into the last few seconds before midnight on the 31st of December. A single human life is less than the final soft blink of the closing year. This is the version most of us have heard, and it is usually told in order to make us feel small and late. Latecomers arriving in the very last seconds, with the great year nearly spent and ourselves a faint footnote at the end of a long book. But that gentle framing has the arrow pointing quietly the wrong way, and the truth is far stranger and, in its own slow fashion, far kinder. We are not at the end of the book, we are resting on its first page. The universe is around 14 billion years old, and the making of new stars, the basic, patient, ongoing work of the cosmos, will continue not for billions more years, but for trillions of them. The smallest, coolest, most unhurried stars will go on burning softly for 10 trillion years, 100 times the present age of everything there is. By any reasonable, gentle accounting, the universe is not in its old age at all. It is in its infancy, its slow, bright morning. The long age of starlight has only barely begun, and we are resting, improbably, in the very first light of it, which softly reframes the whole of the night. We are not the last witnesses, arriving just as the lamps are guttering out. In the great slow clock of cosmic time, the sun is a young star, the earth a young world, and we are early. Almost embarrassingly, almost tenderly early. The thought that the universe is ancient and we are merely its afterthought is a story we have told ourselves at the wrong scale, in the dark. Widen the frame, gently, and it turns over completely. There is very nearly all of time still drifting on ahead. That dark and empty sky of the far future, with the galaxies all fled and the lone island burning quietly alone. That is the universe in its distant old age, and it lies so impossibly far off that the entire history of starlight so far is barely the dew before the dawn. So if you have ever lain awake feeling that you arrived too late into a universe already winding gently down, you can set that down tonight. The soft opposite is true. we are among the earliest minds to wake at all. Inside a cosmos that will go on making light for a span beside which our 14 billion years is a single held breath. And of all that long future light, the most quietly important beam is one that is already here, already arriving. The oldest light there is, the light from the very wall of the observable universe. It has been falling on us this whole time. And for decades, a little of it came to rest. Of all the gentle places inside the family television, when we look as far outward as light will ever carry us, we do not arrive at a galaxy. We arrive, softly, at a wall, a faint, even glow coming from every direction at once, the same in every quiet corner of the sky. It is the oldest light in the universe, and it has a precise and gentle birthday. It set out around 380,000 years after the Big Bang, at the moment the universe first cooled enough to let light travel freely, and it has been drifting toward us across all the time since. We call it the cosmic microwave background, and it is the nearest thing there is to a photograph of the universe as a newborn. Before that one moment, the cosmos was too hot and too dense for light to move at all. A thick, glowing fog of particles, opaque. The light scattering endlessly without ever quite getting anywhere. And then space stretched and cooled past a soft threshold, and the fog gently cleared, and in a single sweeping instant across the whole of the universe, light was suddenly free to fly. That first liberated light is what still reaches us now, stretched by billions of years of expansion from a fierce early glow down into a faint, cold microwave whisper. It is the edge of the observable universe. Not a place at all, but a time. The earliest scene that light can ever show us. Look any farther, and you are looking quietly into the fog, where no image can ever form, and here is the part that gently turns the cosmic into the domestic. Back in the years when televisions caught their signal loose from the air, and you turned the dial to a channel with no station waiting on it, the screen would fill with that restless grey snow, and the speakers would softly hiss. A small fraction of that static, somewhere around 1 part in 100, was not interference from anything on Earth at all. It was the cosmic microwave background, the oldest light in all of existence, born when the universe was a newborn, drifting down onto the antenna in the living room, and showing up, quietly, as flecks of snow on an idle afternoon. People sat in front of the first light of creation and gently complained about the reception. The discovery itself carries a soft thread of comedy through it. In 1964, two physicists named Arno Penzias and Robert Wilson kept picking up a faint, persistent hiss in their radio antenna that they simply could not get rid of, a hiss that came from every direction in the sky equally. They checked everything they could think of. They even climbed up inside the Great Horn and gently cleaned out the droppings of the pigeons that had been roosting there, quite certain the birds must be the trouble. The hiss remained, and it turned out they had drifted, by accident, straight into the afterglow of the Big Bang itself, the single most important light in all of cosmology, and their first patient theory of it had been pigeons. So the wall at the far edge of everything is not some cold abstraction. It poured gently into living rooms for half a century. The largest and oldest fact in the universe spent decades quietly hiding in the most ordinary corner of the house. And the fact that we can read that light at all, that we can measure it and date it and map it softly across the sky, rests on a long, slow, patient climb, because before any of this scale could be known, someone had first to work out how to measure a single distance, to a single star, strip away all the telescopes and all the theories, and one stubborn, quiet problem rests beneath the whole of cosmology. How do you measure the distance to something you can never visit, never touch, never reach? The light years, the 93 billion, the gentle age of the oldest glow, leans in the end on the answer to that one plain question. And the answer was built slowly, rung by patient rung, into what astronomers simply call the distance ladder. Hold up a single finger and look at it with one eye, and then the other, and watch it jump softly against the far background. That gentle shift is called parallax, and the size of the jump quietly tells you how far away the finger rests. Astronomers do the very same thing, using the whole of the Earth's orbit as their baseline, measuring a nearby star from one side of the Sun and then again from the far side, 6 months on, and reading its tiny, soft shift against the more distant stars behind it. It works beautifully, but only for the closest stars. Push much farther out, and the shift grows too small to see at all, and the ladder needs a new rung to carry it on. That next rung came from a quiet, methodical woman at Harvard in 1908. Her name was Henrietta Swan Leavitt, and she was one of a group of women hired to do the slow, painstaking work of measuring and cataloguing stars on photographic plates. Paid by the hour, not permitted to work the great telescopes themselves, their careful labour often folded gently into other people's names. Leavitt was studying a particular kind of star that pulses, brightening and dimming softly on a steady cycle, and in the patient accumulation of her measurements, in plate after plate, she found a quiet law that no one had ever seen. The brighter ones pulsed more slowly, in a relationship so precise that you could read a star's true brightness straight off the gentle rhythm of its blinking. That was the breakthrough that slowly opened the whole universe. For if you know how bright a star truly is, and you measure how bright it merely appears from here, then the soft difference between the two tells you exactly how far away it must rest. Leavitt had quietly handed astronomy a yardstick that reached far past the nearest stars, a way of measuring across distances that parallax could never touch. And within a couple of decades, Edwin Hubble would aim a great telescope at one of these pulsing stars, sitting in what was then gently called a spiral nebula, and use Leavitt's law and prove that the soft smudge was not inside our galaxy at all. It was another galaxy entirely, almost unthinkably far away. The universe had quietly gone from one galaxy to many, and it rode out on a relationship that a woman counting stars by hand had found in the slow blink of distant suns. She did not get to see most of what she had made possible. She died in 1921, before Hubble's famous result, before the full scale of the cosmos drifted into view. Her name known mostly to the people who used her law without always pausing to say so. The rung she gently built, one higher than all the rest, still carries every distance we have spoken softly of tonight. But it, too, reaches only so far, and to measure the truly distant universe, we needed a brighter beacon still. One we found, quietly, of all places, in the depths of stars, beyond the soft range where even Leavitt's pulsing stars grow too faint to read. The ladder needs something that can still be seen across billions of light years. And it found that something, quietly, in a particular kind of stellar death. A white dwarf that has slowly pulled in too much matter from a companion, until it can hold no more, and gently detonates. Blows itself apart at very nearly the same true brightness every single time, almost as though the universe had quietly manufactured one standard lamp and scattered its copies all across space. Astronomers call them standard candles, and they burn brightly enough to outshine whole galaxies for a few slow weeks at a time. The logic is the same gentle logic as Leavitt's, only carried to an enormous scale. If every one of these explosions burns at the same true brightness, then how dim it appears from here becomes a direct, quiet measure of how far away it happened. Catch one going off in a distant galaxy, measure its faint arriving glow, and you hold the distance to that galaxy. Across spans no pulsing star could ever have bridged. And it was exactly these exploding stars, measured patiently across the deep universe at the end of the 1990s, that first revealed the expansion to be quickening. The candles in the dark gently told us that the room was not only large, it was slowly growing, and growing faster all the while. Above even that rung rests a quieter trick still, one that uses gravity itself as a lens. Mass softly bends the space around it, and bent space bends the path of passing light, and so a massive cluster of galaxies, sitting between us and something far beyond it, can act as a vast natural magnifying glass, gathering and gently focusing the light of objects too distant and too faint to see by any other means. Through these gravitational lenses, we catch faint glimpses of galaxies near the very beginning of time, their light bent and softly brightened by the mass in the foreground, smeared into long, quiet arcs around the cluster, like reflections drifting in a warped pane of glass. This is how the deepest records are gently set. The James Webb Telescope, peering outward through both raw distance and these soft lenses, has found galaxies whose light left them when the universe was only a few 100 million years old. One of them, seen as it was barely 290 million years after the Big Bang, its light stretched so far into the infrared by the slow expansion of space that no earlier instrument could ever have caught it at all. We are quietly looking at structures that gathered themselves together when the cosmos was a small fraction of its present age. And they are already there, already shining softly, earlier and brighter than our gentle models had quite expected. So the measurement of the whole universe is not one single act, but a long, quiet chain, parallax, to pulsing star, to exploding star, to softly bent light, each rung carefully calibrated against the one resting below it, each handing off gently to the next at the far edge of its reach. It is a remarkable structure, built patiently over a century by a great many hands, and it carries, quietly, one deep crack running the length of it, because when we measure the expansion of the universe by climbing slowly up this ladder and then measure that very same expansion in a wholly different way, the two answers do not agree. And no one, so far, there are two ways to measure how fast the universe is expanding, and they are both careful, and both carried out by serious people with beautiful instruments, and they hand back two different answers. This is not some small wrinkle waiting quietly to be smoothed away. It has held firm for years, and even sharpened, as both measurements have grown more precise rather than drifting gently toward one another. It has a name now, the Hubble tension, and it rests among the largest unresolved problems in all of physics. The first way climbs the distance ladder we have just built together. Parallax, pulsing stars, exploding stars, out into the nearby universe, and reads the expansion rate directly off how fast the galaxies are receding at their known distances. The second way begins at the far opposite end of time. It takes the oldest light, the cosmic microwave background, and reads the precise, faint pattern frozen softly into that newborn glow, and uses our best theory of how the universe has evolved to calculate what the expansion rate ought to be today. Two slow roads, one setting out from the recent nearby cosmos, the other from the universe's very first light, and the long, patient physics of everything in between. They ought, in the end, to arrive at the same gentle number. They do not. The ladder gives a faster expansion. The ancient light gives a slower one. The gap between them is small in raw terms, a difference of less than 10%. But the measurements have grown precise enough that the disagreement can no longer be softly waved away as simple error. By the careful standards physicists use to decide when a thing is real, this quiet gap crossed the threshold some time ago. Both numbers cannot be right, and every patient attempt to find the mistake, some flaw hidden in the ladder, some misreading of the ancient light, has so far gently failed to close it, which leaves the unsettling, quiet possibility that no one is wrong at all, that both measurements are true, and that the disagreement itself is softly telling us something is missing from our understanding of the universe, some ingredient in the early cosmos we have not yet accounted for, some property of dark energy that shifts slowly over time, some piece of physics not yet written down anywhere. The crack may not lie in the instruments at all. It may lie, quietly, in the theory of everything we have. And I want to be plain about this, gently, because it rests near the very heart of tonight. We have measured the universe with extraordinary care from both ends of its long history, and the universe has handed us back two different answers and quietly declined to explain itself. We do not know which is right, or whether the question even has the shape we have always assumed it has. This is not a gap in a textbook, waiting patiently on next year's edition. It is a live, open, gentle wound in our knowledge of how fast everything is drifting apart. And the people who understand it most deeply are precisely the ones who will tell you, most readily and most softly, that they do not yet understand it at all. So the true scale of the universe is not only unimaginably large and mostly unreachable and possibly without end. It is also, down at the level of the most basic numbers, still genuinely unsettled. And while the careful ones go on quietly arguing over the rate at which everything recedes, something far simpler and far stranger is true of you. Lying here, apparently so perfectly still, you feel still. Right now, the bed is steady beneath you. The room does not move. Stillness seems like the most ordinary fact in all the world. The default, the resting state, the quiet thing that all motion is only ever a departure from. And it is, gently, an illusion. And once you have seen softly through it, it does not quite come back. Begin with the spin. The Earth turns slowly on its axis, and if you are anywhere near the equator, that turning is carrying you eastward at around 1,600 kilometers an hour, faster than most aircraft, while you lie here perfectly still in the dark. Laid gently on top of that, the Earth is racing around the Sun at something close to 107,000 kilometers an hour, so that in the slow time it takes to read this one sentence, you and the whole planet have drifted 1,000 kilometers further along that great orbit and felt nothing at all. And then the Sun itself, carrying the Earth and everything resting on it, sweeps around the center of the galaxy at roughly 800,000 kilometers an hour. That slow quarter-billion-year circuit we drifted through earlier, taken at a speed that would cross the whole planet in under a minute. And the galaxy itself is not anchored to anything. It is falling softly toward Andromeda and sliding with the whole local group down toward the Great Attractor, part of that gentle current through immeasurable Laniakea. Gather it all together, the spin, the orbit, the long galactic sweep, the slow fall toward the attractor, and measure it against the one frame the universe quietly offers. The soft background glow of its own first light, and your true speed through the cosmos, at this very moment, is something on the order of 2 million kilometers an hour. 2 million kilometers an hour. Lying still in bed. The fastest spacecraft we have ever built is the gentlest crawl beside it. You have never, in the whole of your life, been still. Not for a single second. Not even for the soft instant it takes to think the word. Every moment you have ever called restful, every quiet night, every long-held breath, has happened aboard a body drifting through space at a speed the mind has no slot to hold, in a direction you could never point to, carried by slow motions you were never once built to feel. And here is where it comes gently to rest. Back inside the room, the stillness you feel is not a lie your senses tell in order to deceive you. It is a quiet mercy. If you could feel the spin, and the orbit, and the long galactic plunge, all of it at once, you could never rest, never settle, never close your eyes against the rush of it. And so the body softly edits it all away. It hands you a still room and a steady bed, and the simple, gentle sensation of lying down. And it tucks the 2 million kilometers an hour somewhere far back, somewhere you will never have to feel it. The motion is entirely real. The peace is also entirely real. Both are true at once, in the same dark, And the second one is a quiet gift that the first one quietly allows, which leaves, softly, the last strange question of the night, that if we are drifting this fast, wrapped in all this scale, then why does so little of it ever reach us? And why does the sky look so small, and so close, and so still? Step softly outside on a clear night, and the universe will lie to you, kindly and completely. The sky looks like a dome, a dark, close bowl set gently overhead. The stars like points pinned to the inside of its curve, every one of them seemingly the same soft distance away, near enough that the old stories could imagine quietly reaching up to touch them. Nothing in the view so much as whispers of light years, or galaxies, or 2 million kilometers an hour. It murmurs, instead of a ceiling, a low roof drawn gently over the world. And this is not a failure of attention on your part. It is the design itself. The human eye and the human mind were shaped slowly over millions of years to handle one particular range of distances, close enough to matter to a body simply trying to stay alive. How far the leopard crouched in the grass, how wide the river ran, whether that soft shape at the tree line was within a single leap, depth, scale, the felt sense of how far a thing rests from you. All of it is precise and powerful out to perhaps a few hundred meters, and then it simply, gently gives out. Past that quiet range, the machinery never needed to work, because nothing past that range could ever eat you or feed you. Your senses end, more or less exactly, where the danger ended. So everything beyond a few hundred meters is gently flattened onto the same far backdrop. The distant mountain, the drifting cloud, the moon, the sun, the faintest visible galaxy, the eye files them all at roughly the same soft place. Over there, far, with no real difference drawn between the kilometer and the quintillion. It is the quiet spatial twin of what the number sense does to quantity. Both faculties work in fine, loving detail up close, and both gently collapse everything past their range into a single, soft category. Near is detailed and known. Far is simply far. The universe begins, quietly, in the exact place where the equipment stopped bothering. The ancient people who looked up and saw a dome were not foolish, and it is worth saying so gently. They were reading the instrument accurately. The instrument says dome. It takes a deliberate, hard-won, slow act. Centuries of patient measurement, the whole long-distance ladder, the soft accumulation of evidence over lifetimes, to gently overrule what the eye reports, and to set in its place the true, yawning depth that rests behind it. We have done that quiet work. We know now that the dome is not there at all, that the stars hang at wildly different distances, that the backdrop is softly bottomless. But knowing it is not at all the same as feeling it. Stand under the stars tonight, and the dome returns in an instant. No matter what you know, the eye gently reasserting its old kind, lie the very moment the mind glances away. And there is no shame in that, and no need to fight it in the dark. You were given senses for a body, and for a world, and not for a cosmos. They do their quiet job beautifully, inside the gentle range that the job was ever meant for. It is only that the universe happens to lie almost entirely outside that range, past the soft wall of the eye, past the soft wall of the number sense, past the horizon of the oldest light, past the very edge of the measurable. We were never once equipped to hold it, and that, it slowly turns out, is not the quiet tragedy it first seems to be. We began the night together at the number 4, the soft, low place where the mind quietly stops counting and starts, instead, to guess. And we have spent the slow hours since then watching that gentle limit give way, over and over, against thing after thing it could never hold. The marble and the lost star down the dark road, the galaxy we live inside and have never seen, immeasurable Laniakea, and the great empty voids. The bubble that turns out to be the small part, the 94% already, softly, gone, the maybe endless dark beyond the wall, 2 million kilometers an hour, beneath a sky that still looks for all the world like a low and gentle dome. At every step the mind reached out, and at every step the scale drifted calmly past it, and the soft gap between what is and what a body can feel only ever quietly grew. It would be easy, in the dark, to call all of that a kind of defeat. The brain that cannot picture a trillion, the senses that quietly quit at a few hundred meters, the intuition that rounds the whole universe gently down to a lot. It would be easy to read every bit of it as failure, as smallness, as a mind hopelessly outmatched by the vast thing it lives inside. But turn it over, slowly, one last time tonight, because there is another way to hold it, and it is the truer and the softer one. You do not need to comprehend the ocean in order to float upon it. A swimmer does not first measure the depth beneath them, does not count the slow tons of water, does not hold the whole of the sea in their head before they let it gently take their weight. They simply rest on it and are carried. The not comprehending is not a barrier to the floating at all. It is the quiet condition of it. If you had to grasp the whole of the water first, you would never once get in. And the universe is exactly the same. The mind that cannot hold its scale is not locked out of it somewhere cold in the dark. It is held by it, completely and gently, whether it understands a thing or not, the way the swimmer is softly held by a sea they will never measure. And that quiet flat line at the number 4, that soft heading where everything large is folded gently under one patient word, it is not only a limit, it is also, in the dark, the doorway out of all the vertigo. It is the reason you can lie here, drifting at 2 million kilometers an hour, wrapped in horizons and voids and unreachable light, and still feel the simple steadiness of a bed and a dark room and a slow held breath. The mind's gentle refusal to render the full scale of things is the very thing that lets it rest inside them. The comprehension would quietly crush you. The not comprehending sets you softly free to sleep. So let the largeness stay large and uncounted. Tonight, let the galaxies recede and the dark drift on past the wall, and the true size of everything remain unknown, perhaps forever. None of it asks anything of you. You were never asked to hold it, only to be a small, warm, breathing part of it, made of more atoms than there are stars in the sky, carried softly through the dark at a speed you will never feel on a young world in the first light of a very long morning. Together tonight, we drifted past the nearest marble and out through the immeasurable heaven, to the soft edge that is always wherever you are, and gently back again into the small dark space your ribs make each time you breathe. We did not manage to hold the universe. No one ever has. And the universe held us anyway, the whole quiet while, without ever once being asked. If this is the kind of night you return to, subscribe. It helps this quiet universe keep growing. The universe will still be here when you wake up. So will we. Good night.